Have you ever thought about what's going on behind the doors at Ericsson's booth in Barcelona? That is the kind of the question we're trying to answer for you today. So we're here for one of the exclusive Ericsson broadcasts from Mobile World Congress. Tonight we're going to talk about cloud-based networking. And I'm Peter Linder. I'm going to be your host here today. See me as a proxy for yourself, trying to ask the questions you would have asked if you're here. Also have my colleague Saan Ilmonen, who's going to manage all the questions that's coming in. So the way we're going to do this, we're going to cover 4 different areas during the session here, and we'll give you the chance to ask questions during all these different sessions. So we're going to start here straight away with Sean Cryan, and we're going to talk about the whole cloud space. What's driving the cloud conversations that's going on right now?
Great question, Peter. Well, I mean, if you look at North America, what's really been driving the shift to cloud native over the last number of years, operators have been getting their networks ready to launch 5G services. And when we speak to our customers, they see that cloud native is really a critical enabler. I mean, if you just think about it, we're decoupling the software from the underlying infrastructure, breaking it into smaller components. So what it gives you is much more cost efficiency and that agility and flexibility to launch new 5G services and to scale up based on demand. So our customers see that this is a critical enabler to be successful in 5G, and we've been supporting on many transformations over the last year, and we see that's going to continue into 2023.
Yeah, I remember working with virtualization and cloud and so on. What do you see, and it's like with different types of topics and interesting things going on here. What is it that's driving the conversations that you are having here this year?
Right, great question. I mean, there's been lots of great conversations over the last few days with our customers. I mean, I think the main thing, one big topic that's coming across is flexibility. I mean, our customers are coming across saying they want to be able to support our cloud native applications on different environments, looking at the public cloud, looking at the private cloud. More and more we see that hybrid deployment scenarios, hybrid cloud scenarios are actually coming to the fore. So I think the challenge and the conversations around how do you support all of these different deployment scenarios in a seamless way for customers. So this is a lot of the things that are driving the conversation. I think the second big topic is around automation. I mean, that's a huge topic of conversation at the moment. And I mean, if you think about the cloud, we're building applications to give you flexibility, but they need to be managed in a very different way. And I think what we realize when you look at 5G core and look at the complexity and the volume of services, without automation, you can't really get the benefit of moving to cloud native. So that's another big topic driving the conversation.
Yeah, and if you look a little bit forward from this perspective, what are the key trends that is going to drive us this year, next year?
I mean, I think the big trend, we see this continuing. I mean, we see customers continuing to opt in to get the benefits of cloud native. So that's going to continue into 2023, 24. I mean, ultimately, we believe that anything that can benefit from being on the cloud will eventually move to the cloud. Yeah. We started with IT applications, moved to the core. The next one was, of course, in the radio. There's a lot of conversations happening about Cloud RAN, how you can take that same microservices architecture and get some of those similar benefits on the radio as well. So we think those future topics will be about how do you actually build networks in the best way with a combination of both purpose-built and Cloud RAN to give the best result for their customers. So Cloud RAN is going to be a big topic going forward as well.
Drilling a little bit on that question, you have deep experience both on the IT side, on the core side. Now when radios, which are coming in perhaps the last network functions to getting into the cloud, what are the key things that people should, what are the key learnings from the core and IT deployments that we should bring with us when we're trying to move the radio parts?
I think one thing I'd highlight is it's not just about the application and the technology, right? I mean, that's a part of it. But one of the things we see with our customers is that it's also the operations. It's a completely different way of working when you actually start to go into a cloud native world in terms of how do you deploy software, the CI/CD pipeline, the impact on the operations. So again, I think the key lesson learned would be the technology is one side of it, but the impact on the operations and how to manage that in a real operating environment, that's another lesson that we need to take to the future as well.
Yeah. Anything that you think all customers in North America should know about Ericsson and the cloud space?
I mean, I think the main thing is, we're committed to be leaders in this space. I mean, we're really doubling down. We've been listening to look, I think one of the things to call out is we've helped our customers go live with a lot of new cloud native applications. Yeah. There's been a lot of learnings, a lot of additional areas we can focus on in terms of automation. And I think the main thing is we're committed to be the leaders in this space and make sure we have the best technology for our customers.
Yeah, I think that's a great takeaway for everybody here. We're going to run talking to everybody and the rest of the team here. Thank you very much for being here on the show tonight.
Thanks so much, Peter.
Okay, so with that, we're going to take you down to the first station here. And as you see here, This is an extremely exclusive opportunity you have here because we have totally emptied the whole hall for you. And we're doing this because we want you to be able to talk to the business builders and get their undivided attention, because most of these stands were probably jam-packed with people on a normal day. So here, we're going to go talking about 5G core. Christer Boman, what is going on? What do you see as it? We're introduced 5G with 5G PC, and we're now about taking the leaps to 5G core everywhere. What is driving this, and what is shaping that market?
I mean, right now, what we're doing here today, we have a huge amount of operators that are live with our 5G core and also packet core, generally speaking, on cloud native infrastructure. So we're talking about the 4G PC, 5G non-standalone architecture and 5G standalone architecture, everything on cloud native infrastructure. And what is driving is basically, I think there are two transformations here, right? One thing is the cloud native and to gain benefits and access to the cost reduction opportunities and do more automation in terms of software upgrade, etc. 5G core standalone architecture, new business opportunities that will be sorted out now here in the near future, basically. So those are key drivers.
Yeah, and you and I, we've talked about these kind of things from ages. When we've gone through the journey, the whole journey on the core side towards, well, we went from purpose-built to virtualized, and now we're doing it towards cloud native. How would you compare those two shifts and the challenges in introducing these?
There are major shifts, right? Before we had an integrated platform with the hardware supplied by Ericsson operating system and also the application on top of that. So every fully integrated by Ericsson, end-to-end verified, full support, etc., etc. So going to virtualized and now cloud native, where we see that there is a major impact inside, Ericsson and of course our customers, all the people, there is a learning curve. Processes have to be updated as well to cater for this new infrastructure with this new platform. So there are numerous things that have to be sorted out now that will be challenging.
Yeah, and if we look at this, and we're talking about cloud native, but there's also a couple of different options here that we have regarding how we can host the cloud native network functions.
Yeah.
The whole thing between private and different kinds of public.
Yeah.
What are the options there, and how is the conversations going?
I think the starting point right now, I think that we have what we call the Ericsson full stack with our NFVI and CNI platform. 80% of our customers are using that one. Then they have full access to the end-to-end verification and full support from Ericsson. And then in parallel, we have maybe 20% of the customers, they are going third-party cloud, VMware, Red, and OpenShift. We fully support that. We are totally agnostic to the underlying infrastructure and hardware. Moving forward then, we also see a trend. Many customers are asking here about the hyperscalers, private cloud, public cloud, hybrid cloud. And I think the starting point here will be, in order to meet the telecom grade requirements, to start with private cloud and over time migrate toward public cloud.
So where would you say on a scale that the 5G core, where does it fit between IT application, which perhaps easiest to migrate, and radio application perhaps a little bit?
Yeah.
How do these... What is the nature of these different network functions or capabilities from cloud readiness, or how easy it is and how fast it's moving to the cloud?
I think right now we have 29 live customers on the cloud native infrastructure. So it's a journey, but right now we have done the learnings. The quality is good for mobile broadband, 4G, 5G, voice in service or software upgrades or also in place, I would say. So I think that we have all the main capabilities to move forward with APC and so on.
Yeah. So how hard is this on the operator's organization? From how much do they need to transform to take full advantage of the cloud?
It's a big transformation inside the operator's organization, I would say. It impacts across, but I think that the software is there, so I think that will take out some of the complexities out of the equation. Cloud native is a totally new platform, so there will be a learning curve inside the organizations.
Yeah.
Yeah.
And if you take your crystal ball, not like the binocular, so we look 10 years out in the future, but what are the things that you see happening now, 2023, 2024, on a global basis that the North American provider should be aware of?
I think that we will see more and more operators picking up the cloud native platform. And then I think that there is also a lot of work on getting the new revenue opportunities going that the 5G core can actually offer in the market. For instance, network slicing is a very hot topic here, so that you can sell an enterprise slice with premium price, basically. And then I think that another thing that is picking up here in 2023 timeframe is the roaming capability on top of standalone architecture. Roaming is a fairly complicated feature, far more complicated compared with EPC. There are new network elements, security has to be in place, and you have to upgrade the complete network. We see that national roaming is picking up this year for mobile broadband and data, and then VoNR will come next, and we will have also international roaming. So those are some of the key areas: network slicing and roaming, and also exposure, I would say, is something that we try to develop the business for as well.
Yeah, so one thing I'm a little bit curious about is here, when we talk about network slicing, we've been talking about it for quite some while. What are the key advancements that's taken place recently to show that, hey, this is ready for prime time?
I think that, first and foremost, we have explored a lot of different use cases together with many operators across the globe, and we start to realize, understand what have the capability and opportunity to actually be adopted out there. Underlying technology is also evolving as well. We have had a number of different options. Now we see that the technology with the URSP, UE route selection policy, is being adopted. Also the device vendors will implement support. And then we can have the capability to dynamically add slices, remove slices, work also with the edge computing dynamically. So those are the key technology components that we see moving forward now.
Yeah, this is a really good summary of what, like, covering the whole field.
Yeah.
So with that, I would like to turn back to Sian in the studio. What kind of questions do we see coming in?
Hi, Peter. So the first question, what are the latest global deployment stories from standalone and 5G core?
Yep. So what are the latest stories or deployment stories that we've seen for 5G standalone and core? Any interesting examples you would like to point out?
We have numerous journeys that has been done across the globe. We have, for instance, SKT in Korea. They're doing bare metal successfully. We have Telstra, Rogers with the full end-to-end Ericsson, also going to explore the network slicing. So we have numerous of those examples that are more brought forward. British Telecom is another major operator that have also implemented the optimized user plane that we have. So our user plane has the capability to integrate boxes that have been standalone before, like firewall, TCP optimization, NATing, etc., is fully integrated within the Ericsson packet core gateway, meaning that you reduce significantly the amount of east and west traffic that is required, so you can actually do cost savings in terms of cloud infrastructure. So some examples of key customer cases.
Yeah, any more questions?
So in which order do you see hybrid cloud option to be adopted? Are we talking about private and hyperscale first, or public? Which way?
I think that what we have done, we have started a journey now with the major hyperscaler providers, Amazon, Google, and Microsoft. I think the first step has really been to understand and also share the requirements for telecom-grade applications. So that has been agreed upon. So we are moving forward, and that means that we will start with private cloud in the initial phase, and then explore public cloud and the potential elasticity that can provide moving on when you would potentially need additional capacity and so on. So that's my view.
Yeah, but it's really good.
Yeah.
Any final question from the audience?
Oh, that's it. Thank you.
Really good.
Yeah.
Thank you very much, Krista. It's a pleasure as always to tapping into your insights, and for customers in North America, you're no stranger.
Yeah.
You've been there a number of trips, and we're looking forward to see you back over there soon again.
Yeah, definitely. I lived in California, Silicon Valley for 3 years, so I'm looking forward to come back, definitely.
Great. Thank you very much, Krista.
Thank you very much, everyone. Thanks.
So from this stop, we talked about the 5G core, and I hope you took away that we were playing with a number of different components here. It's a transition from 5G EPC to 5G core. We're talking about the transition from virtualized to cloud native, and also we talked about different kind of cloud realizations. So from that, we'll take you to the next stop here is where we're going to talk Cloud Run.
Hello, Peter.
Pleasure meeting you, Frank. You've been here now. We've been busy for 3 days talking Cloud Run.
Yep.
What are the benefits of Cloud Run that resonates with people?
First of all, work on the cloud first. So most of the benefit as Cloud Run does provide to network is the segregation between software and hardware. So basically, it's more like it provides you a buffet menu that you can grow your network as you need, either on hardware level or on a software level. It's totally match with network strategy as you want.
So with drilling into that, what are the kind of trade-offs? And you say, hey, I really like these benefits with Cloud Run or virtualized Run. What are the trade-offs you're facing in?
Okay, so currently, so if we compare to our purpose-built RAN, so versus Cloud RAN, so we're looking at probably 3 or 4 different, let's say, key parameters to compare against. Currently, we see capacity-wise and efficiency-wise, our purpose-built RAN over there has more capability and more efficiency performances. Cloud provider most is the flexibility, portability, and scalabilities, especially when customers starting to look at the overlay of networks or want to gradually to grow the network as a coexist network building between 4G, 5G, and the new 5G and the new networks.
So this kind of flexibility, who is interested in that flexibility and for what purposes?
So there are a couple of scenarios. So one scenario is for existing large deployments, customer would like to introduce new spectrum or new use cases. I think they have a parallel network with the existing network running our purpose build that introduce Cloud RAN based design in order to enable new applications, new use cases, for example, enterprises, or a private network. They can take the Cloud RAN from day one.
No, that sounds really exciting. If we drill into the different conversations you're having here, it seems like this high performance thing has been pretty much a central conversation.
Yes.
What do you talk about there?
Okay, so high performance is as you know, the cloud industry has been going for a long way. So the cloud infrastructure and the general computing semiconductor industry has been enhanced year and over year. Now it's about a time that we take advantage of the mutualization of the cloud industry as well as the CPU general compute, allowing us to be able to apply our Ericsson layers of the protocols to the general compute to be able to bring the full experience into the cloud infrastructures.
Yeah, and how do we work with Ericsson to secure this the high performance of the Cloud Run?
So the performance on that is they take advantage of the generational over generational of the enhancement from CPU, as you can see for the industry for the past 2-3 decades. We do see enhancement over and over. Then the cloud benefit is the software and hardware disaggregation, as we showcase over here. Once this new CPU is being enhanced, we can take exactly the same software we had from previous generation, apply to the new CPU, not only portable, but also in order to write on more capacity from the CPU. So therefore, the high performance to start very humble, but when CPU grows, we naturally, with our software portability, we can enhance our performance generations and generations with a very short time TTM, time to market.
Yeah, so it sounds like here one of the key things that we are doing is like we're cutting time from when the new generation is out. And
I won't call that a cutting time. We'll optimize the integration and introduction cycle, but and essentially we are reduce the introduction cycle from our software with hardwares, and also allowing customer to be able to, as I said early on, due to the disaggregation between hardware and software, customer can select to either evolve the hardware first or evolve the software first as network needs goes. It's very flexible. And also we embrace the cloud principle, the continuous integration, continuous design is always in the loop, allowing us to have a much more faster feature and integration deliverables to customers.
So how does this change how service providers has to think about at their end when they were used to purpose-built technology to now introducing Cloud Run? How does it change how they work and introduce this in their network?
So first of all, I think the whole industry probably comes into realization already. the cloud-based infrastructure is the future to go. So from service provider standpoint, if they're starting to build or embrace a cloud-based infrastructure to be able to introduce compute on the RAN features, that's the first step. Then they work with us. We can work with them. Depends on their network strategy, whether it's going to be coexisting for some time between the purpose-built or the cloud-built, or we can work together to introduce a overlay of the cloud-based 5G, as currently we're doing with some of the customers in US.
Yeah, it's really good. Yeah. So one thing, the other thing that we talked about a little bit earlier, you and I, was a little bit about this energy consumption. What about Cloud Run in an energy consumption perspective? What do you see there?
Perfect question. So as you know, energy consumption has a big issues around the world. Yep. And also energy consumption has a big issue for CPU as well, not only for our RAN purpose, RAN application, but also in the general gaming and data centers. So we took a full advantage of this feature set from general computing. For example, Intel, they have the C1, C2 states and also the P states. But basically, what it does is it tune down the voltages or manage different caches in order to save the power when there's no need for that. But what the benefit of Ericsson design is that we design our software layer 1 to layer 3. Every single code is ourselves. And we know how RAN works. So we control the scheduler. We know exactly the service will come. We know exactly when UE is going to have a call. Then in this case, we can adaptively to adjust the usage of the voltages, the usages of the cores in order to achieve the best energy efficiencies. And we have showcased over here based on some of the early tests, even with very dynamic usage of the network, we can save easily 10%.
Wow. No, but it sounds like here that even you talk about the decoupling, there's quite a lot of things that are happening to optimize it the way we're trying to bring it back together again.
I would say slightly differently. We use the hardware, general hardware. For example, when it comes down to power efficiency, all the CPU vendors from Intel and AMD, for example, they all provide some of the fundamental features and hardware level about how to control their voltages, how to control on and off of their cores. The key thing is the software. Yeah. Software use that fundamental algorithm as infrastructure and to apply the intelligence on top. So I have to quote a famous one from my previous VP, say, hardware is easy, software gives the soul to hardware.
That's a really good one. I'll give you that one. So I guess we can't talk about a subject like this without understanding what role does AI play in the concept of Cloud Run?
Perfect question again. So I'm not going to use example about the power saving again. I'm going to use some of the AIs currently where I try to experiment on the dynamic MCS adaptation, which means MCS means you have to adjust different coding schemes when you come in and out. So we take a full advantage of our cloud infrastructure. As you know, AI is largely running on the cloud infrastructures. So instead of using a previously predetermined algorithm as currently we'll be using in the 4G, 5G, now what we're doing is we're trying to replace that with AI-enabled algorithm. So basically when customers are walking along the way, that we're going to adopt or predict, not only even predict, is also doing the conditional adaptive. When you is walking right away, then MCS is going to adjust as it goes. So basically, let's imagine the reaction of the MCS adjusting in the sub-TTI level.
Yeah. Oh, that's really good.
Yeah.
So, but before you're off the hook, we have some questions from the audience here, I think. Or am I right or wrong on that one?
Yes. So the first one, is this Cloud RAN going to substitute the purpose-built RAN compute?
So is Cloud Run going to substitute the purpose-built RAN compute, or what do we think there?
A wonderful and tough question. I have to say that. So I have to look at it in two different phases. If you're looking at the vision-wise, the whole industry's evolution-wise, if like 10, 20, or 30 years view, if we will believe the general cloud computing, put all the data application running in cloud infrastructure computation, I think that's the entire world, our world, will migrate into that cloud-based computation. So therefore, from that perspective, we we believe, as the hologram was showing early on over there, we believe everything will be computed, processed in the cloud. But if we're looking at, since we're engineers, we're delivering our solution to you in near to midterm, we have to say coexist is the key for these cloud introductions. As I highlighted early on, if we're looking at a comparison between purpose-built and cloud, purpose-built is still, from capacity, from efficiency-wise, is still leading. Clouds provide more towards flexibility and portabilities. But when time goes by, cloud take advantage of the CPU computing evolution, we can get more and more capacity and enhance our efficiency as we go. But so basically we're seeing a parallel and merging and sometimes a crossing network network strategy. That's the beauty of Ericsson. We have both purpose-built as well as the cloud-built. Then we can cope with you to deploy your network depends on your spectrum asset, your network strategy, and your traffic evolutions. So to help you to get the most benefit out of both solutions, or parallel, or slow migration, or long migration. Basically, it's a buffet of Ericsson.
That's really good. Any more questions?
Yes. With the hardware and software disaggregation, there will be more open interfaces. So how secure is Cloud Run?
So the question is here, like with more open interfaces when you're doing this aggregation, how secure is Cloud Run compared to purpose-built?
Okay, so Ericsson's answer of openness is within our Cloud Run product offering. So I have to say, from technology-wise, that is all of our designs from CU to DU, from DU to RU or radius, all the interfaces are Cloud Run compliances.
Really good. Any final question from the audience?
No, thank you.
Okay, I've got the final question for you. Okay. When we're talking about 5G in all different shapes and form, low band, mid band, high band, where are we with which types of band can we support with Cloud Run today?
Currently, we enable all of them.
All of them?
They're all live working. Some of them in North America, some of them in the continental Australia.
Really good. Thank you very much, Frank. I'm proud to have you as a colleague and sharing your wealth with our North American customers today. See you back at base.
Thank you, Peter. Welcome to the cloud.
Yeah, thank you. So we've digged into the 5G core, and we have also talked about Cloud Run. And right now we're going to share a little bit of session with our Spanish-speaking part of the world. Hola, ¿cómo estás, señor?
Muy bien, ¿cómo estás, Peter?
Yeah, oh, sorry, that was a bad joke. We're back into the English speaking session for US and Canadian customers. RAN automation, service management, orchestration, RAPs. There's a lot of things going on here, and some of these architecture very much influenced with the open RAN development that we're in the middle of right now. How do you help us positioning the service management, orchestration, RAPs in this whole field?
Yeah, service management and orchestration is the industry alignment that is trying to address the market trends we see towards more openness, disaggregation in the overall architecture of the network, automation, and the cloud nativeness of the whole, not only network, but the management systems. So this is what this Open RAN SMO concept is trying to address as an industry alignment.
Yeah. And when you talk about this and describe this whole field, what is it that we're trying to do differently for people than what we've done in the past?
It's an excellent question, because sometimes we can say it's another OSS, it's another network management system. It's really not. I mean, for us, it's more like the evolution of the OSS. It is a very strong foundation of a very strong platform that sets the foundation for a set of, in this case, called RAPs, the applications that implement the use cases of radio automation. But you can think of that as, that may be extended to some other domains. Because in this way, the objective, the main target of the whole architecture and the philosophy of it is, let's make the applications as lean as possible, as thin, as simple as possible. They can focus on the use case, because the platform will take care of everything else.
So, when where does this fit into the evolution journey? Do you start with Cloud Run and then you do service management orchestration as a later phase, or are they how are they coupled together and how are they coming to life?
Not necessarily. It's true that the Open RAN SMO it's being aligned in the Open RAN community, but because the concept we think is so valuable, we actually want to take it beyond Open RAN or Cloud RAN. That's why our intelligent automation platform, which is our implementation of the SMO concept in Ericsson, will be supporting not only Open RAN and Cloud RAN, but purposeful RAN, both for Ericsson and non-Ericsson.
That's really good. So help us understand, RAPs have always puzzled me. It's like perhaps one of the things I personally have struggled to get my head around. What are some of the kind of early RAPs that's coming to market, and what do they do for service providers?
Yeah, for those of you familiar with the self-organized networks portfolio set of use cases, you can think of all these being promoted as RAPs on top of this platform. That's kind of the trivial use case, and that's from the beginning part of the portfolio evolution. But not only so. I mean, the RAPs we are discussing with the early customers go from software management RAPs like Canary Upgrade to be able to keep your RAN software updated continuously automatically and validate automatically on the network. That has a massive influence on operations because you can think of automating the software upgrade of hundreds of thousands of sites with the safety of knowing that we've been testing that against an AI pre-validated model in the lab. We have things like energy management RAPs, RAPs that are taking care of managing and monitoring the energy consumption in the radio network, which is triggering a whole set of different use cases, not only energy efficiency, but just the fact that we are able to monitor the energy consumption will open different use cases. And some other use cases like performance diagnostics, that's another of the early ones, which is basically monitoring 4G and 5G network, every cell in the network, monitoring more than 250 KPIs, and running more than 300 different root cause models to understand which is the root cause for any problem in any of the cells of the network in real time.
Wow, that's pretty impressive. So if those are the early applications, what do you see coming next?
We see a lot of interest in extending the Open RAN SMO, extending the RAPS ecosystem, because the other foundation of our go-to-market with in the SMO area is that we were offering an SDK together with the platform. We are offering a software development kit just from day one, because we want to promote the creation of new RAPs. And that creation of new RAPs will imply not only, let's say, RAPs by themselves, but connections to other BSS systems, OSS systems, external systems. Some of the use cases we always discuss is, imagine we can introduce weather forecast information in the radio planning and radio optimization aspects, so that the radio is actually aware that a hurricane is coming, so that the radio can be prepared to compensate for that automatically as soon as something happens. So all these sort of integrations with other domains that were not actually present on the radio so far, we think is going to open a whole set of new value on the radio management.
So, and this is not only for the hurricane, preparing the radios for not blowing off the tower, this is more or less dealing with the rain and the changes in...
Yeah, any change in the radio. I mean, things like, and even some other very interesting cases that some of the early operators are discussing with us. For instance, this is now a radio domain management system you can think of, but still they are very interested in adding KPIs from the end-to-end experience measurements on the quality for end users, so that the radio is able to react to degrading quality of experience on the end user. Independently, maybe what's happening on the core, what's happening on the transport can be somehow fixed by changing things on the radio in real time. So that's something that will affect as well how the radio is being managed.
Wow, no, this is really cool. Anything I haven't covered here that you've been speaking here frequently about that's like representing the key conversations here in Barcelona?
Well, we get a lot of questions about the openness of the whole thing. And on one side, we are implementing all the open interfaces defined by the Open Alliance, the O1, the O2, the A1, the R1. So that part of the openness comes native. The SDK in the sense of opening the platform to everyone. And then the amount of work we do with the Open Alliance in actually writing the specifications and writing and trying to drive this industry alignment, I think probably speaks for itself in that area.
No, but I think it's one of our key contributions to the work and making sure that this particular piece is part of the puzzle and not only some of the other interfaces.
And the other question we get a lot is, when can we do a trial of this? So there's so much interest, in almost every operator you can think of.
Oh, that's really good news. So I think we've covered a lot of questions here, a lot of ground, and we could speak here for perhaps half an hour. But I would like to hear, do we have any questions from the audience on this particular topic?
Yes, how will this impact the installed E&M base, like Ericsson Network Management Base?
Yeah, as part of the definition of the SMO entity, there's actually what is called the SMO decomposition. So the SMO itself, as a management and orchestration function, is actually decomposed in 3 functions. One is the radio operational maintenance, the other is the orchestration of the cloud resources, and the third one is what is called the non-real-time run intelligent controller, the non-real-time RIC. The operational maintenance and the cloud orchestration can most likely, and will most likely in many cases, basically uplift existing infrastructure, existing systems like our E&M or our Ericsson orchestrator. So those will be extended to support, for instance, the open interfaces in the case of E&M, and this will become part of the solution, the SMO solution. So the objective is making the best use of the install base and limiting the footprint to the minimum possible to provide the functionality we want.
Really good. Any more questions that we're picking up?
Yes. Will anyone be able to develop our apps and use it on the platform?
That's a very good question. And just as a proof of how much we believe in the openness of the solution, from day one, from launch back in November 21, we already presented InfoVista and Viavi as companies that are interested in working with our platform. And we have some updates from Viavi, especially in Mobile World Congress, that we have even some quotes from their CTO explaining how easy it is for them to work on this platform. And we need to take into account that it's still early days. So that's the one we can present. That's the one we can actually talking about publicly here in Mobile World Congress. But we have a long list of requests from other companies that want to start trying our SDK and our development environment.
Yeah. Any final questions from the audience?
Yeah, so how is this AI involved in our apps to improve the network?
That's an excellent question. Actually, AI is in the foundation of the SMO. There's so much expectation in the community that AI should help to fix a lot of things in the operations, basically, of the radio, that we are taking that to heart, and even to the point that we are including an AI execution environment directly on the platform. So the Arabs will they just need to come with a model, and we will take care of that, of executing that. Of course, not every Arab will have an ML model with it. Many of them will, but not all of them will. Which comes as well, to the point of the Arabs will be collaborating themselves. So some of them will bring AI to maybe generate trend discovery or anomaly detection, and they will share these KPIs, they will share these insights to some other apps that may not need AI because they are reusing the AI from some others. Oh. So it's really on the foundation of the whole thing.
Oh, that's really good. One thing that I've picked up here a lot, there's been so many conversations of both how can we drive up 5G revenues for service providers, but also how can we drive down OPEX. Where do you see this fits into that equation? Is this like a primarily revenue driver that allows people to create more services and applications on top, or is this driving down OPEX primarily? Where does it fit in the equation?
We think most likely the short term will be an operational efficiency driver. Things like canary upgrade or all the automated optimization will go directly to optimize the network easily, more frequently, with lower cost. Mm. But at the same time, we're pretty convinced that the fact that the operator is able to have better control of the radio may influence the kind of, for instance, service level agreement commitments they can do. So whenever we talk about 5G monetization, slicing comes into it. And you will be able to monetize as much as you can guarantee. And for guaranteeing, you need to actually monitor it. Mm. So as much as we provide the operators with the capability to keep the control of their slices, the quality they're providing, as much in real time as possible, as much automated as possible, we are allowing to all these revenues to happen. So there will be some let's say, extra monetization aspect as well.
Yep. That was really exciting. I guess we could stand talking here for half an hour easily. I would like to thank you for standing here with us tonight and talking to our American customers, and also sharing your wealth of insights regarding this fascinating field. And I'm quite sure that it will have evolved a lot until we're here back here next time. Thank you very much.
Thanks a lot. Thanks a lot, Peter.
Pleasure.
Thank you.
So now we're going to come over to this session here. And have two of my colleagues here. So this is the topic that's a little bit, well, I wouldn't say that's trickier than others, but we have excellent talent that I would like to expose to you. So help us understand this. We talked a lot about now, we talked about 5G core, we have been talking about Cloud Run, we talked about service management orchestration. Where does automation and AI fit into this puzzle?
Okay, so basically what we are trying to do with AI is make more efficient any activity that we are doing in the networks. Basically, from planning to optimization, we are trying to get to be more efficient in the capex allocation. We want to be more efficient in the OpEx perspective, and we want to get the maximum return of investment out of the network. So basically, we are dealing with a very high complexity right now because we are deploying 5G standalone, non-standalone. We have multiple layers in 4G, new carriers, new frequencies. We have Cloud Run. We have many different ways of deployment in the networks. And if we start to multiply the effort to do all these tasks, with manual activities, is going to be impossible to deal with. So basically, we are using AI to be as efficient as possible. The simple automation were not possible anymore because we need an entity, we need an algorithm that is learning from each network on how the network is performing, how it's behaving. And after that, we will need the algorithm to take some action. Basically, that's what AI is doing.
So it's almost seemed, I'm listening to the conversation, everybody talks AI, it's every single station here pretty much in the stand, and like key conversation across the whole event. And it almost feels like wherever you take a whole business operation, you break them out into a big spreadsheet, wherever there are red dots in that one, say, hey, we need to attack this one with AI.
Exactly.
It's like, so is this a true representation of the world? How deep and how far does it reach?
When you are, if I understood correctly, is how deep we go into the issues that we find?
Yes, no, it's a little bit like AI is not only something that we talk about everywhere. It's something that you have really
specific.
It's very specific.
Exactly.
Like sounds like you pinpoint the problems pretty much down to a cell in an Excel sheet and starting attacking it.
Exactly. Yeah, it's actually very touchable because we, especially in the part of the engineering, we know that we have to deal with, real customer complaints, real problems with interference, problems with, mobility, for example. And these type of problems, which is, the daily basis, and, we have our troubleshooters dealing with them, need to be fixed. And the AI is going to dig into each of the issues. It's going to find the root cause of each of the problems. It's going to provide even the recommendation. So that is, we are talking actually about a closed loop. So we go from detection to classification, root cause analysis, which is going to indicate which are the parameters that need to be fixed, and then a recommendation to fix it. So it's actually the whole cycle that that's an example of AI, what AI is doing. But we have many algorithms to do many things. So we have incident management, for example, where the algorithm is going to predict if there is going to be a critical issue by getting a history of the cell, and is going to take action even before it happens. Even before the issue happens, it's going to take some action, automatic action. We have AI, for example, for energy management that is going to orchestrate or manage all the features related to energy. And the way it does is the AI is going to predict how the traffic is going to behave in the network, and depending on that, is going to change the configuration of certain features, or it's going even to lock a cell if it's not needed, or to activate the deep sleep. So AI is really present in the network, and it's really, it's not an idea. It's actually a software that is predicting how the network is going to behave and is going to take actions.
So cognitive software, what is that really doing and helping us with?
Yeah, well, cognitive software is the whole package of software, different modules that go from planning. So we have in the planning phase, we have certain products, AI products that the AI algorithm predicts how the traffic is going to evolve, or yes, what is the evolution of the traffic in the next year, and it's going to help the operator to make a plan related to capex, where to invest. So you can maybe, I don't know, have as an input, for example, you can say, okay, I'm going to disconnect the 3G network. I'm going to move the traffic from 3G to 4G. At the same time, I'm going to start the 5G network, non-standalone. My objective is to move 10% of the traffic. So the planning, the capacity planning, which is the name of the algorithm, is going to tell to the operator exactly what to do month by month. So now you have to do these activities, optimization activities. You need to have this many carriers to expand. You need to install these sites, and it's going to tell you where to install the sites. That is in planning phase. Then in optimization, I already said some information about, for example, the performance diagnostics, which detects the issues, and also the energy management. But we have, for example, another AI automation that is the geolocated diagnostics, which is going to evaluate all the signaling from all the users in the network. Is going to geolocate all the information in the map, and is going to analyze each of the calls, each of the connections, so that it gives you some insights on how to optimize the network and get maximum out of it.
Really amazing. So Ian, when all of these things are going on the software side with automating of everything, how does it affect how we introduce the software into the network? We've already taken the leap towards DevOps, but what is happening in the way we introduce the software in the network?
So what we're working with is a concept called ML ops, or machine learning ops, and it's taking the concepts of DevOps into the machine learning so that we can efficiently scale and manage these AI models that we're putting into production and all through our systems. So what we're doing is looking at the different tasks that we have to do in the life cycle, like we have to ingest the data, we have to transform the data, we may need to normalize it, then we do feature engineering, then we build models, we test the models, we see how accurate they are, we may use different algorithms, tune hyperparameters, and then be able to push it out into production. But unlike just normal software, machine learning models need to be monitored, and if they're not performing well, trigger an automatic retraining so that we can get models that are in production that are accurate and maintained. So to be able to do that at scale, when we go from tens of models, hundreds of models, thousands of models, tens of thousands of models, what we're doing is working on a common AI foundation, we call our telco ML ops, to be able to enable that.
So how is this equation affected by when we're now moving to, we're talking about microservices and perhaps not launching a whole new software suite at long intervals, but more coming with smaller pieces as part of the puzzle? How does this solutions help for those kind of challenges?
So when we have, let's say, multiple models, let's say even these microservices have their own models, what we can do is we can interlink with a CI/CD software pipeline so that when those microservice development are coming through the traditional pipelines, we can have a parallel MLOps pipeline that can drop the models into the various microservices, test and deploy them. So that's how we do it, at scale and with efficiency.
And how far would you say we have come with this today? Is this something that's on the drawing board, or how far have we come with the realization of this?
So in different parts of the company, we've been doing, various work in this area of creating technology stacks to be able to deliver these kinds of capabilities, but it's become fragmented across the different BAs and different SAs. So what we're doing is looking at how we can converge onto this common AI framework. So we've started the process of that analysis, and we're looking for a decision to be able to productify this.
Yeah. So this is something that is happening then across multiple network functions, and we're doing it in a way so that it helps people driving the agenda. And we're doing a lot of these things internally before we kind of drinking our own champagne in the sense that we implemented our own processes before we doing release it for customer-facing activities. I think that gives us a really good perspective of how we're taking advantage of both AI for automation and for the introducing the software. So I would like to turn to you. Do we have any questions from the audience on this particular topic?
Yes. How long has Ericsson been doing AI and automation?
Yeah, that's a good question. So Manuel, how long have we been doing this?
Yeah, actually more than 10 years. Yeah, we have a long history, even before 2010, of doing automations. And we are talking about AI specifically, is around 2010 or 12 approximately that we were starting to work in the development of AI. And in the last, around the last 5-6 years, we have been using and selling the software to operators. Currently, we have 60, specifically 59 customers.
Roughly 59.
59 customers currently using the software, and we are optimizing almost 12 million cells with it.
12 million cells.
12 million cells with it.
That's a pretty mind-boggling number.
Yeah.
So second question, I think we have a lot of questions coming in here.
Yeah, this cognitive software is definitely very, very interesting. So are we also working with smaller organizations like airport and ports?
So for the cognitive software, are we also working with smaller organizations, smaller implementations of airports and ports?
Yeah, well, we, for example, even though the clients are the operators, until now we didn't have any client that was like a private client. But yeah, I mean, the implementations can be in the smaller places. Like, for example, we had now in the World Cup, so we did an implementation for the stadiums. So we can use the AI specifically for an event, for example. We can use it in the airport, we can use it in a small cluster, or we can use it in the whole country. We have in China, in the whole country, in 2 of the main operators, and for example, in any, Olympic Games, for example, World Cup, we usually use all AI to improve the networks.
Okay, really good.
Yeah, and what are the deployment options for these features?
So what are the deployment options for these features and capabilities?
So there are 3 types of deployment. We have the standalone deployment, is the one that we have been using in the last years. Basically, we can do it in a local deployment, we can do it remotely, we can do it in cloud. Whenever a client is asking us for a deployment, we are going to do a quick study. In 1 week, we are going to let the client know what is going to be the hardware needed. If they don't want to deploy the hardware in their premises, or they prefer to be that kind of transparent for them, we can do software as a service. That means that we are going to install the software in our premises, and then they're going to access as if they had the software on their own. We have also the MLOps platform, which is going to allow to develop new software, and Ian can talk more about it, more details. And we have the apps, which you already saw. So all the AI that we have is going to become an app. Actually, is becoming an app right now. And the idea is to be able to deploy it in an open platform. So that's the 3 types of deployments.
Yeah. Any kind of additional color you will put in that question, or does this pretty much cover the perspective?
I think it pretty much covers it. I think when we talk about the MLOps, I think that's really about helping the scale to scale it up, right? So it helps really in the development phases, and then the deployment is, of course, either on the premises, in the cloud, or as an RAP.
Yeah. Any final question from the audience?
Yeah, final question. Does Ericsson has any AI built for hardware failure prediction? If so, is this deployed?
Yeah.
So, got any capabilities or any for understanding,
Yeah.
identifying hardware failure?
Yeah. So we have two. We have the performance diagnostics. One of the items in the classifications per issue is the hardware issue. Could be also intermodulation issue. That's another one. But I mean, definitely there is a how is in one of the classes where the diagnostics classifies the issues, and the other one is the incident management. Incident management is going to detect if there is a hardware problem, and is going to trigger certain actions to solve it as soon as possible. And even, I mean, one of the actions can be to send the service on field to fix it.
Yeah.
So these are the two ways. One, the diagnostics will be based on the pattern of the KPIs per cell. So if the cell has a certain pattern which fits with one of the hardware problems, that is going to send an information, an alarm on that. And the other is the incident management, which is more real time. So whenever it happens, in a few minutes, it's going to send to trigger certain actions.
Really good. Thank you very much for this really fast speed dating on the whole field of AI and automation, and really appreciate what you shared with us here and our North American customers.
Thank you to you.
So with this one, we are approaching the end of the show here. I think what we've tried to do today, making sure that you not traveling to Barcelona is not necessarily a showstopper from not taking advantage of all the best learnings here. We wanted to create a really exclusive experience for you. And as you see here, you're the only customer that matters right now. If you like this session, share it with your colleagues. The session will be available online as soon as we stop this live recording or live broadcast. The second thing, also, if there's anything ideas that this has triggered, anything you would like to follow up, reach out to your account manager or Ericsson representative or someone's managing your relation, or send me a mail, peter.linder@ericsson.com. This is the final series for North American customers from us here in Barcelona. We've run 3 shows for you, one on 5G revenue generation, one on energy efficient networks. If you haven't seen any of those, strongly recommend you to tune into those ones as well. And also give us feedback on what you think about these sessions. We think this will represent more of what we will going more of in the future. We see there's very, very high quality in the conversations that we're having here in Barcelona, but we also know that there are many of you that would like to take advantage of this. So give us feedback how you think this works regarding format, interest, and so on. And because we'll be back in the not too distant future. Thank you very much from us here in Barcelona. We are very, very thrilled. We are very, very exhausted. And that is the kind of feeling that most of the people leave Barcelona with, especially when you've had the opportunity to spend your time in this fabulous booth. Thank you very much.